Welcome to another SmartTech Tech Draw tutorial. In this tutorial, we will be demonstrating the procedure for constructing a parabola given the span and the axial length of the parabola. For this example, the axial length will be 130 mm and the span 75 mm. We begin the procedure by drawing a rectangle. Start the rectangle function by using the command REC and then click on the workspace to indicate the first corner of the rectangle. Type D and then hit enter so that you can input the dimensions of your rectangle. The length of the rectangle should be equal to the axial length and the width of the rectangle equal to the span. Click on the workspace to place the rectangle. For this procedure, we need to divide the axial length into any number of equal parts and the span into twice the amount of equal parts. For this example, we will use 5 and 10 parts. To divide the axial length into equal parts, we draw an adjacent line to the axial length. The angle and the length of this line are to your discretion. Then we scribe 5 arcs starting from the intersection of the adjacent line to the side of the rectangle. All the arcs must be equal in length. In AutoCAD, you may scribe one arc, then copy it using the array function. To do this, you select the arc you wish to copy, then use its intersection with the adjacent line as the base point. Type A, then hit enter to start the array function, and put 5 as the amount of array items. Placing your mouse at the end of the line makes sure that the angle of the array is the same as the line angle. Input the radius of the first arc as the distance for the next object in the array and press enter. Draw a line from where the arc intersects the adjacent line to the end of the side of the rectangle. Use copy to draw parallel lines to this one from each of the marks adjacent to the line. Trim the excess of each of the parallel lines. The same thing should be done to divide the span, except the amount in this array will be 10. The array function may be used to copy the lines as well. The second point in the array will simply be the next mark on the adjacent line. Trim off all the excess. Next, we need to draw horizontal lines from each of the marks on the span. Draw one of the horizontal lines, then use copy and array to draw the others. Keep in mind that the array would only consist of 9 this time, since the opposite side of the rectangle would make the 10th object. Transpose the divisions from the bottom to the top of the rectangle. Use the line function and then place your cursor over the first division mark. Move your cursor upwards so that it shows the vertical polar tracking indicator. When your cursor reaches the rectangle's top side, click to place the first point in your line, then move further upwards to complete the line. Copy this line across using the division marks below it as the base point and the other marks at the bottom side as the second points. From the center point on the span, draw lines to all the division marks on the top or bottom. Use the mirror function to make inverted copies to the top or bottom. We now have all the points we need to sketch the parabola. Use the spline function to sketch the parabola. Starting from the top right corner of the rectangle, the next point is where the oblique line touches the next horizontal line below. The next point after that will be where the next oblique line touches the next horizontal below, and so on till you reach the vertex at the center of the span to the left. Once you reach the vertex, you continue to all the points below the center line. And there you have it, a parabola with an axial length of 130 mm and a span of 80 mm. Thanks for choosing Smart Tech for your tech draw learning. If you found this video helpful, then like and subscribe. Hit the notification bell so that you know when we upload new tutorials, and keep practicing.